Hello, today our presentation is going to be on the Radial engine. We have Alex as a cameraman and we have Robert doing the slides. And I, Matthew, will be presenting. So we did the Radial engine. So on the left hand side you can see what our Radial engine actually looks like. It's got 6 cylinders, the flywheel up front. This is what an actual Radial engine looks like. Everything's covered up, ours is a little more open so you can get a gist of how it works. So a little bit of history on these Radial engines. These Radial engines were used in World War II, especially in the bombers. Now the reason they used these engines was because they produced a lot of power. These engines had a very short crankshaft, and so they were able to output a lot of power. So a little more history on these Radial engines is they actually used to use them in order. So you would have one Radial engine, let's say with 7 cylinders, and you would have another Radial engine. So you can put as much as, we've seen 7 rows of these engines put together, which is 28 cylinders. Now, some airplanes in World War II that used to use this was the B-36 Peacemaker. That was a very important airplane in that time. The only issue that these Radial engines had was that although they produced a lot of power for the time, they would get very hot. The reason is because the air would come in through the first Radial engine, and by the time it got to the seventh obviously got hot air, and so those pistons would get really, really hot, a lot of combustion, and they would catch on fire, which wasn't reliable. So the Radial engine was basically used before and then after they got the turbojets to replace this one. This is a video animation clip of how a Radial engine works. So as you can see, this Radial engine is very similar to how a 4-stroke engine works. It's got a 4-stroke cycle just like any other engine. It's got its intake, its compression, its power or spark, and then its exhaust. As you can tell, this engine works in a clockwise order. Like I said, it has a very short crankshaft, which is able to output a lot of power. In conclusion, we've learned over this semester a lot of things in SolidWorks, and we were able to put everything together for this project. So as you can see in this project, we learned a lot of tools in SolidWorks, creating mechanisms to use multiple parts, moving parts. We use projection and engineering, technical drawings, part modeling, part drawing. For each part that we made drawings. We used geometric dimensioning and tolerance, assembly and assembly drawing. We were able to assemble everything with the mates, and even mechanism design. So in this project, we were able to group together a lot of what we learned throughout the semester. So we're very thankful for that. Thank you for watching.